Hello everyone, today we're going to revise the force questions. A small positively charged sphere is suspended from a thread and placed close to a negatively charged rod. When the thread is 45 degrees to the vertical, the system is in equilibrium. The weight of the sphere is W and the magnitude of the electrostatic force between the rod and the sphere is F. What is the magnitude of weight W compared with the magnitude of electrostatic force F? As the system is in equilibrium, resultant force in X component is 0, resultant force in Y component equals to 0. So tension has two components. Y component is adjacent, that's T cosine theta. X component is opposite, that is T sine theta. Resultant force in Y component equals to 0. That means T cosine theta minus W equals to 0. That is W equals to T cosine theta. Substitute the theta 45 degree. As a system in equilibrium, resultant force in X component also equals to 0. That means F minus T sine theta equals to 0. Rearrange. F equal to T sine theta. Substitute theta. That gives us T sine 45 degree. As we know, sine 45 degree equals to cosine 45 degree. That means W equals to F. C is correct answer. A skier is pulled up a hill by a rope at a steady velocity. The hill makes an angle of 12 degrees with the horizontal. The mass of the skier and ski is 73 kg. The diagram below shows the three of the forces acting on the skier. On the diagram, draw and label one other force acting on the skier. So we can see there are normal reaction, friction force, and tension in a rope. So missing force here is weight. So W downward, and we label as W or weight. B. Calculates the magnitude of the normal reaction acting on the skier. So normal reaction is in Y component. Weight has X and Y component. Here we focus on Y component. So Y component of the weight is adjacent, that is W cosine theta. As the object is moving parallel to the surface, resultant force in Y component equals to 0, which means R minus W cosine theta equals to 0. R equals to W cosine theta, and the weight is equals to mg. Substitute values. Mass is 73 kg. Acceleration due to gravity 9.81. Cosine 12 degree. That gives us 700 Newton. C. The total friction force acting is 65 Newton. Determines the tension in the rope. The tension is in X component. So we need to find X component of weight first. That is opposite. That is W sine theta. The skier moving upward direction with a steady velocity, which means resultant force in X component equals to 0. As the object is moving along the slope in upward direction, T minus W sine theta minus friction equals to 0. Rearrange. Tension equals to mg sine theta plus friction. Mass is 73. Acceleration due to gravity is 9.81 times sine 12 degree plus the friction 65. That gives us 240 Newton and 210 in two significant figure. Two block of weight 5 Newton and 2 Newton are attached to two rope X and Y. The block hang vertically. The mass of the ropes is negligible. What is the tension in X and the tension in Y? Let's focus on a smaller weight or smaller mass. Two forces acting on it. Weight 2 Newton tension Ty. As the object is translational equilibrium, resultant force in y component equals to 0. Ty minus 2 Newton equals to 0. Ty equals to 2 Newton. Now we combine two objects. So total weight is 7 Newton. And the tension is Tx. As the object is translational equilibrium, resultant force in y component equals to 0, which means Tx minus 7 Newton equals to 0. Tx equals to 7 Newton. Correct answer is B. A particle accelerates from rest. The graph shows how the acceleration A of the particle varies with time t. What is the speed of the particle at t equals to 6 seconds? The graph is acceleration time graph, and the question is asking the speed. So, area under the acceleration time graph gives us changing velocity. So, when we have an acceleration time graph, area under the acceleration time graph is changing velocity. So, area equals to 1/2 times base times height. That is 1/2 times base is 6, height is 3. That gives us 9. As we know, area under the acceleration time graph is change in velocity. So change in velocity equals to 9 meters per second. And change in velocity is final velocity minus initial velocity, which is 9. We rearrange. Final velocity equals to 9 plus initial velocity. As the particle accelerates from rest, initial velocity equals to 0. So finally, we get 9. Correct answer is C. A stone block is pulled at a constant speed up in incline by a cable attached to an electric motor. The incline makes an angle of 12 degrees with the horizontal. The weight of the block is 1.5 times 10 to 4 Newton, and the tension T in the cable is 4.2 times 10 to 3 Newton. On the diagram, draw and label arrows that represent the forces acting on the block. Based on the diagram, the tension force is given. So we have a weight, downward direction, and normal force, perpendicular to the surface. As the object is moving upward direction, then we have a friction down the slope. Calculate the magnitude of friction force acting on the block. Friction force is parallel to the slope. So we need to find x component of the weight. That is opposite W sine theta. Block is moving upward direction with the constant speed. Resultant force in x component equals to 0, which means in upward direction, tension minus downward direction, W sine theta minus friction equals to 0. Rearrange. Friction equals to T minus W sine theta. Substitute values. Tension is 4.2 times 10 to 3 minus weight is 1.5 times 10 to 4 and times sine 12 degree. And that gives us 1.1 times 10 to 3 Newton. A diagram below shows the force acting on a block of weight W as it slides down a slope. The angle between the slope and the horizontal is theta. Normal reaction force on the block from the slope is N and the friction is negligible. Which of the following gives the resultant force on the block? Normal force, and we have the weight. The weight has two components. Y component is adjacent, that is W cosine theta. And x component is opposite to the theta, which is W sine theta. As the object is moving along the slope, the resultant force in y component equals to 0. which means normal force equals to W cosine theta. Normal force and the y component of the weight, W cosine theta, cancel out. So only force acting on an x component is W sine theta. So object is accelerating along the x-axis. So net force in x-axis equals to ma. And in a net force in x-axis, we have W sine theta. And the correct answer is A, W sine theta. A velocity time graph for an accelerating object that is traveling in a straight line is shown below. Which of the following is a change in displacement of the object in the first 5 seconds? Velocity time graph is given. The question asking change in displacement. So area under the velocity time graph gives you change in displacement. So area equals to its triangle 1/2 times the base times the height. That is equals to 1/2 times base is 5, height is 5. That gives us 12.5 meter. Displacement is equals to 12.5 meter. A trolley moves down a slope as shown in figure 4.1. So slope makes an angle of 25 degrees with the horizontal. A constant resistive force Fr acts up the slope on the trolley. At time t equals to 0, the trolley has a velocity v equals to 0.5 meter per second down the slope. At time t equals to 4 seconds, velocity equals to 12 meter per second down the slope. Shows that the acceleration of the trolley down the slope is approximately 3 meter per second. We know the final velocity, we know the initial velocity, we know the time taken, so acceleration is going to be final velocity minus initial velocity divided by time taken. Final velocity 12 minus initial velocity 0.5, time taken is 4, that gives us 2.9 meter per second, which is approximately 3 meter per second. II. Calculate the distance x moved by a trolley down the slope from time t equals to 0 to t equals to 4 seconds. Based on our data booklets, we have s equals to initial velocity plus final velocity divided by 2 times the t. Plug in the values. Initial velocity 0.5 plus final 12 divided by 2 times time taken 4. That gives us 25 meter. On the figure 4.2, sketch the variation with the time t of the distance x moved by the trolley. As we know, the object is accelerating down and acceleration is 2.9 meter per second. And we are requested to plot variation with the time t of the distance x moved by the trolley. We have a line with the increasing gradient and a non-zero gradient at origin. You can see from the graph the gradient change. The gradient of the displacement time graph gives us velocity. So the gradient change, velocity change. Change in velocity or change in time is acceleration. Shows that the component of the weight of the trolley down the slope is 8.3 Newton. Component of the weight of the trolley down the slope, that is parallel to the slope, and that is the x component of the weight, which is opposite W sine theta. Weight down the slope equals to W sine theta, which is mg sine theta. Mass is 2, acceleration due to gravity 9.81, and sine 25 degree, and that gives us 8.29 Newton, approximately 8.3 Newton. Calculate the resistive force Fr. We know the acceleration from the previous slide. Acceleration is 2.9 meter per second, and we know the x component of the weight, which is W sine theta, which is 8.3 Newton. as the object is accelerating down, resultant force in x component equals to mass times acceleration. Resultant force in x component is W sine theta minus the friction, which is equals to ma. W sine theta we calculated earlier, 8.3, minus we are looking for friction. Mass is 2 kilogram and acceleration is 2.9. That gives us friction force equals to 2.5 Newton. A force of 7.5 Newton acts at 40 degrees to the horizontal as shown in figure 1.1. Calculate the component of the force that acts horizontally. So horizontal is this one, which is adjacent. Adjacent is cosine theta equals to fx over f. And the horizontal component of the applied force is f times cosine theta. Plug in the values. 7.5 times cosine 40 degree, that gives us 5.7 Newton. Calculate the component of the force that acts vertically, that is opposite to the 40 degree. That is sine theta, which is Fy over F, and y component of applied force equals to F times sine theta. Plug in the values. 7.5 times sine 40 degree, that gives us 4.8 Newton. Two strings support a load of weight 7.5 Newton as shown in figure 1.2. One string has a tension T1 and is at an angle 50 degree to the horizontal. The other string has a tension T2 and is at angle 40 degree to the horizontal. So object is in equilibrium. Determine the value of T1 and T2 by using vector triangle or by resolving forces. Okay, so first thing we need to resolve T1 and T2 in x and y components. X component of T2 is adjacent, T2 cosine 40 degree. X component of T1 is also adjacent, T1 cosine 50 degree. Y component of T1 is opposite, that is T1 sine 50 degree. And lastly, y component of T2 is opposite, that is T2 sine 40 degree. The load is in translational equilibrium. So resultant force in x component equals to 0, resultant force in y component equals to 0. Let's focus on resultant force in x component. That is T2 cosine 40 degree minus T1 cosine 50 degree equals to 0. Rearranging, T2 cosine 40 degree equals to T1 cosine 50 degree. We need to find T2, so T2 equals to T1 cosine 50 degree over cosine 40 degree. That gives us 0.84 T1. Now let's take a look at y component. As the object is translational equilibrium, resultant force in y component equals to 0. So in upward direction, we have a T2 sine 40 degree and a T1 sine 50 degree. Downward direction, we have a 7.5. So upward minus a downward. T2 sine 40 degree plus T1 sine 50 degree minus 7.5 equals to 0. Now we need to substitute T2. T2 is equal to 0.84 T1 from the previous slide. And then sine 40 degree plus T1 sine 50 degree equals to 7.5. If we solve this, we get T1 equals to 5.7 Newton. Substitute T1 into our first expression, we get 0.84 times 5.7, which gives us T2 equals to 4.8 Newton.